We did find life. Bacteria at the depth of 24,600 feet.
Scientists were very surprised that life could even exist or could be found that deep.
Under Russia's frozen Earth is a hole so profound it almost reaches the Earth's secrets itself, an area where years of drilling stripped away layers never intended for viewing, only to be exposed by scientists to things that were illogical and unexpected, because what they discovered at the bottom wasn't what anyone anticipated, leaving us wondering if this hole could be keeping something the world wasn't supposed to discover. This is the tale of the Kola Superdeep Borehole, officially named SG-3, one of the greatest scientific endeavors in the history of mankind, an undertaking that tested the limits of engineering, patience, and curiosity to their extremes. Situated on Russia's far-flung Kola Peninsula in Murmansk Oblast's Pechensky district, just north of the Arctic Circle and near Norway's and Finland's borders, the project was conceived in the Cold War era as a visionary Soviet endeavor aimed at searching the deepest secrets in Earth's crust. Drilling commenced in 1970 under the leadership of Soviet geologists and engineers, and although America had concentrated on sea-floor drilling in experiments such as Project Mohole, the Soviets targeted the continental crust, determined to penetrate deeper than anyone before them. Engineers designed highly sophisticated rigs that could sustain phenomenal pressure and scorching subterranean heat, developing equipment that was not previously tested at such high levels. The drill bit spiraled down gradually, year by year, with new meters offering new challenges and compelling the team to continuously innovate, rethink, and adjust. They altered drill bits, enhanced cooling systems, and tweaked drilling methods to avoid collapse or overheating, while the world observed the project evolve into a monument to Soviet scientific pretension, not a competition with other nations but with nature itself. By 1989, after almost 20 years of tireless labor, the Soviets had achieved an incredible depth of 12,262 meters, the deepest man-made place on Earth, still today. This was beyond the depths of the oceans of the world and beyond the height of the world's highest mountains, and took the Kola Superdeep Borehole to the level of a feat unmatched by any other scientific or engineering endeavor. But what made this tale so interesting was not only the depth itself, but the revelations en route, revelations that blew expectations out of the water, rewrote the textbooks, and left scientists with more questions than answers. When drilling commenced, scientists were hoping to validate long-standing theories regarding Earth's crust. Seismic studies had suggested that about 7 kilometers down, the solid granite layer would transition into denser basalt, a boundary known as the Conrad discontinuity. For decades, this was taught as fact in geology classrooms, but as the drill bit dug deeper through the Kola Peninsula, that expectation unraveled. Rather than encountering basalt, the drill was continually striking granite, but this granite had been greatly metamorphosed, altering under the intense heat and pressure but never transforming into basalt. This discovery was stunning. The seismic signals that geologists had been taking to signal a change in rock type were actually alterations in the granite itself, so geologists had been reading their equipment incorrectly for decades. Textbooks were rewritten, seismic interpretations reinterpreted, and a whole new humility adopted. The deeper we drill, the more we realize we do not really know what is beneath our feet. But the surprises continued. Perhaps the most stunning discovery at the Kola Superdeep Borehole was that liquid water existed miles beneath the surface where everyone thought it did not. It had been assumed that in such heat and pressure, water would not be able to exist in liquid form, but the drill found pools of water over 3 kilometers deep. This was not just normal groundwater seeping in from higher levels but water that was locked into the crystalline form of the rocks themselves, preserved for millions or even billions of years. It existed not in cracks but in tiny pores and voids locked away by impermeable boundaries. The significance was staggering. If water could exist in such extreme environments, it may affect earthquakes, mineral creation, and tectonic processes, serving as a secret force behind Earth's restless motion. More to the point, it left open the possibility that microbial life could also exist in such sealed systems, a suggestion of life existing where there was supposed to be none, a clue not just about Earth but about the potential for life elsewhere in the solar system. Even the drilling mud, the lubricating fluid to cool and stabilize the equipment, came back with astonishing findings. Rather than simple fluid, it returned to the surface foaming and bubbling with gases, virtually boiling. Hydrogen was the main gas released in overwhelming quantities, along with helium, nitrogen, and carbon dioxide. None of this had been modeled for Earth's crust, which had always been assumed to be chemically stable and quiescent at such depths. The hydrogen indicated chemical reactions such as serpentinization, in which water interacts with iron oxide minerals, and the helium implied radioactive decay far down in the crust, but carbon dioxide and nitrogen teased the still more intriguing prospect of microbial metabolism, generating rumors of deep Earth biospheres. That previously envisioned lifeless, soundless world beneath the surface was suddenly seen to be dynamic, reactive, and even possibly biologically alive. As if this was not enough, the drilling made microscopic fossils pop up from 6 to 7 kilometers below, embedded in solid granite. Fossils of single-celled planktons were just about 2 billion years old, almost an unpossessable discovery because fossils are normally in sedimentary rock created close to ancient oceans, and not in granite smelted under high pressure and heat. And here they were, undisturbed as ancient sea whispers, hinting that at some point in the past, seabeds and sediments had been pulled deep into the continent's crust, entailing life along with them. That they lasted for billions of years under such conditions was unbelievable, trapped in time capsules made of impenetrable rock. This smeared the distinction between geology and biology, demonstrating that the history of Earth is not just inscribed upon its surface but also far beneath it. The deeper the drill went, the more bizarre everything became. Temperatures shot much higher than expected. Where models had predicted around 100 degrees Celsius at some depths, instruments registered 180 to 190 degrees. This record heat warped drill bits, toasted sensors, and shattered lubricants, creating almost impossible conditions of work and straining Soviet technology to its limits. This unforeseen heat also cast doubt on basic assumptions regarding the flow of energy inside Earth, indicating that the crust must be thinner or more convoluted than previously assumed. Concurrently, rocks previously thought to be unbending, granite, basalt, gneiss, began acting strangely. Rather than breaking, they bent and flowed like plastic, sealing around the drill as if alive. It was this odd ductility that accounted for the way the tectonic plates moved, mountains folded, and earthquakes broke out, demonstrating that Earth's crust is not rigid but ever so slowly moving, pulsing with life even in its most rocky layers. Compounding the confusion, certain layers were denser than predicted, with pores and spaces full of water, undermining pressure distribution assumptions and models of crustal uniformity. Rather than pressure building steadily with depth, stress built up in an irregular manner, providing new understanding as to why certain areas were more prone to earthquakes than others. Each layer appeared to be a thorn in the side of expectations, demonstrating the crust was a mosaic of complications and not a uniform shell. It was always, perhaps. Hints of bizarre chemistry and even life itself lurking deep underground continued to surface. Hydrogen, methane, carbon dioxide, all possible means of chemosynthetic energy, were there. Scientists were speculating on extremophiles, bacteria that could possibly survive in bubbling heat, crushing pressure, and total darkness, feeding not on sunlight but on chemical reactions. The finding of ancient fossils only added fuel to the speculation. Could endoliths, bacteria living inside rock, be thriving there today? If so, then the Kola borehole could have discovered not only the secrets of geology but the concealed biosphere of our own Earth, a glimmer of life in the most unlikely places. But even with these revolutionary findings, the project was confronted by insurmountable issues. Disaster hit in 1984 when a 5-kilometer stretch of drill string broke off within the borehole, clogging the shaft and compelling engineers to change direction, drilling anew. This mishap, topped by escalating heat and pressure, made headway more difficult. Every new effort stretched equipment to breaking point, and even when technology worked, politics did not. The breakup of the Soviet Union in the early 1990s sucked the finances away, and the project withered. The vision of 15 kilometers never came to be, and it drilled only slightly more than 12 kilometers. Left behind was a capped metal door in the Arctic wasteland, punctuated by rusting towers and abandoned structures, a reminder of ambition over technology and politics. The collapse of the borehole echoed the collapse of its neighboring towns, which were previously full of workers and their families but now rested in silence and decay, memories of a time when science and geopolitics were intertwined. What had started out as a testament to Soviet strength and human ingenuity ended up as a desolate reminder, a muted echo of engineering's limitations when pitted against the unyielding force of the Earth. But even in defeat, the Kola Superdeep Borehole was to leave its mark. It showed that the more we drill, the less we understand, and that it teased us with secrets yet to be revealed. If the project had gone on, perhaps the findings could have changed the world. More drilling might have told us how the crust of Earth gives way to the mantle, refining tectonics and earthquake science, possibly saving lives with enhanced forecasting of natural disasters. It may have discovered additional mineral reserves or geothermal resources, revolutionizing energy production. It could even have given us more conclusive evidence about where life began and whether microbes might survive in great depths below or elsewhere in the universe. Now the original location is capped, but the dream persists. New technology, advanced materials, artificial intelligence monitoring, and collaboration with global nations could ultimately achieve what the Soviets abandoned. Japan, Germany, and other countries have begun new drilling operations, carrying on the work of delving deeper into the secrets of the planet. The Kola Superdeep Borehole might no longer be in operation, but the essence of it lives on, a testament to the ingenuity of human curiosity, persistence, and the fact that there is a world beneath our feet waiting to be discovered. So the question is, which of the Kola borehole discoveries shocks you most? The boiling gases, the fossils millions of years old, the concealed water, or the potential for life to exist miles below the Earth's crust, where everyone assumed it could never possibly survive?